Let's discuss question number 39 from test 3. This is from strength of material, so I'm just writing SOM. A steel wire of 10 mm dia. So you have taken a steel wire where the diameter is 10 mm, is bent into a circular arc. So you want to make this into a circular arc of 20 meters radius. Okay, so you have just applied moments like this, and you have finally got a steel wire which is of this form. Okay, now maximum stress is asked, maximum stress induced, and Young's modulus is given, which is 2 into 10 power 5 Newton per mm square, basically steel. Okay, and another thing that is given is radius of curvature, which is 20 meters. Now one of the assumption which we have to do here is that though this is a large strain problem, but we analyze that the behavior, because now elastic behavior is the behavior of any material is elastic only up to very small strains, and once your strain increases say more than 0.2 percentage, which is typically the yield strain, after that it's all plasticity. So we assume that the behavior is elastic. That's the only thing you can assume, because plastic behavior we don't study at the BTech level. So that's the valid assumption, and assume elastic behavior. So when we assume elastic behavior, this is basically a pure bending problem. And pure bending problem, I can use the bending equation, which is m by I sigma by y E by R. So what it says is that so in this problem, basically I have applied moment, I get stress induced in the cross section, basically the flexural stresses. But in this problem, what is required is the radius of curvature is given. So we'll be using these two, the second and the third part of the problem. If I take a cross section somewhere here, it's a cross section like this. Okay, and y is basically the distance from the neutral axis being the centroidal axis, and it is at the center here because it's a regular circular cross section. So y is basically your d by 2, which is your 5 mm, and the stress induced is obviously the maximum stress induced at y is equal to d by 2. Okay, so we can find by this second and third part where so E is Young's modulus, this is 2 into 10 power 5, y is diameter by 2, basically at the outer periphery, so 5 mm. This is radius of curvature, which is given, it is bent into a circular arc. So radius of curvature for a circle is basically its radius, so 20 meters I am just converting to mm. So now by this I get so by this I get 10 into 10 power 5 by 2 into 10 power 3. So basically it becomes 100. So basically 50 Newton per mm square, the same units of Young's modulus because we have used everything in mm. So I get 50 MPa. So the answer is basically a direct application of this bending problem because the loading is bending. So the answer is 50 MPa. Option is B. Thank you.